Hello and welcome again. In this video we are going to start working out an example problem. Now you can find the exact same example worked out in the lecture notes, so if you want to read about it you can always go there and check it. Now since the problem is actually quite long, I will split it up into multiple videos. Not only does that keep the videos relatively short, it will also allow you to easily find back a certain step later if you want to revisit it, for example while doing the homework assignments. Now the example we'll look at is the following one. 2 bars, one horizontal, one under an angle, with a load of 1 kN applied on the top right node. Both members are made from the same material with an E modulus of 70 GPa and a cross section of 10 mm squared. The dimensions are also provided on the sketch. It is 100 mm high and 125 mm wide. Now just note that just as all figures in this course, the figures are just a sketch, so always check the dimensions. Now before we dive into this example heads first, let's first take a step back and think about what we want to do, since this is the first example we work out. Do you remember lecture 1? At the time we discussed that there are basically 3 main parts in an FE problem, namely pre-processing, processing and post-processing. And the pre-processing step was again divided into multiple steps. Since I realized these different steps may not be fresh in your memory anymore, I'll remind you of them before we go any further. The first step was discretization. Then we go to idealization. Next, the equilibrium of each element was set up and the whole system was assembled. The final step in pre-processing is the application of loads and boundary conditions. And afterwards we are left with a matrix that we have to solve during the processing step, and we can find the derived results such as stresses and strains in the post-processing steps. Before going into these steps, let's pick a global coordinate system, which is always the very first step to do. And this global coordinate system does not need to be special. We can use the standard XY coordinate system with the x-axis being horizontal, so parallel to the top element, and the y-axis vertical, so the load is in y direction. The discretization is straightforward in this case. You can see that we have 2 elements, so we will discretize it using these 2 elements. There's no need to use more elements in this case. Now let's just add a node number to the figure so it's easier to refer to the nodes. The node in the origin is defined as node 1, and in this case I numbered the nodes in a counterclockwise way. And the elements I'll name A and B. Normally we also number the elements, but to make the distinction between elements and nodes a bit easier for this first example, let's use letters rather than numbers. Now that the nodes are numbered and the elements labeled, we can also set up the connectivity matrix. And in this case the first row connecting to element A is going from node 3 to node 2, so that it is parallel to the x-axis and in the same direction. If I would have ordered them differently, the rotation angle would be 180 degrees, which also works out, but requires a bit of additional work, so let's avoid that for the time being. The second element, element B, goes from node 1 to node 2. Again, the order is important mainly to define the rotation angle in one of the later steps. The second step to do is the idealization. This basically comes down to selecting the kind of element we will use. In this case we will of course use truss elements, since this lecture covers truss elements. While this step may be trivial in the context of this lecture, I do want to emphasize the importance of this step. By selecting these elements to be truss elements, we ignore any bending stiffness they have. Also later on, if we use finite element software, it is very important you realize the kind of element you use to idealize your structure. It is the single most important assumption you will do during the finite element analysis, so choose wisely. Now I'll stop the video at this point, since up to now it has been mainly about setting up the problem and we have not gone into the details about the matrices and transformations just yet. In the next video we will set up the element equations and rotate them to the global coordinate frame. So see you there.